Welcome to the Deep Dive, where we uncover the core insights from the latest breakthroughs. Today, we're exploring an exciting new report from Google.
That's right. It's called Gemini 2.5, Pushing the Frontier. And it covers, well, a lot. Reasoning, multimodality, long context, and agentic capabilities.
Quite a title.
It is. The report introduces the whole Gemini 2.x model family. So you've got the new Gemini 2.5 Pro and 2.5 Flash, but also the earlier 2.0 Flash and Flash-Lite.
Okay.
And our mission today is really to unpack what makes these models, especially the new ones, so significant. Their unique strengths, how they're pushing AI forward.
So listeners will get a clear idea of what these models are, what they can actually do, and how they compare.
Exactly. What makes them tick?
All right, so let's dive into this family. Google seems to be creating like a spectrum of models here, from super powerful to more efficient. What's the big picture?
Yeah, that's a good way to put it. What's really compelling about the Gemini 2.x family is it covers that full range. It lets users tackle complex problems, but, with different needs for performance versus cost.
Makes sense.
And a key thing, every model in this generation is natively multimodal.
Meaning they handle different types of data seamlessly, text, images.
Text, images, audio, video, yeah, even entire code bases. They're built for it from the ground up. Plus, they also support long context. We're talking over a million tokens.
A million, wow.
And they have native tool use built in, so they can understand these huge data sets from all sorts of different sources.
That's a really powerful foundation. So, okay, walk us through the specific models. What are the key differences?
Right. So top of the line is Gemini 2.5 Pro. This is their most capable model yet. It's getting state-of-the-art results on really tough coding and reasoning benchmarks.
Okay.
They call it a thinking model. It really excels at multimodal understanding, can process like 3 hours of video content in one go.
3 hours?
Yeah. And it's this combination, long context, multimodality, advanced reasoning that unlocks what they call new agentic workflows. We'll probably get into that one.
We definitely should. What else about Pro?
It's also really good at generating interactive web apps, understanding code at a whole repository level, and it even shows some emergent multimodal coding skills. Pretty advanced stuff.
Okay, so that's the flagship. What's next?
Next is Gemini 2.5 Flash. This one still offers excellent reasoning, but uses much less compute and has lower latency.
So faster and cheaper, but still smart.
Kind of. They call it a hybrid reasoning model. You can actually control its thinking budget. So it's good for most complex tasks where you need to balance quality, cost, and speed.
Interesting. And the others? The 2.0 models.
Right. Then you have Gemini 2.0 Flash. That's described as a fast, cost-efficient, non-thinking model. More for everyday tasks. And finally, Gemini 2.0 Flash-Lite. Fastest, most cost-efficient, really built for use at massive scale.
Okay, quite the lineup.
Right.
But you mentioned thinking models for the 2.5 Pro and Flash. That sounds different. How does that thinking part actually work? What's the impact?
Yeah, this is a really key development. Previously, Gemini models would, just generate an answer pretty much immediately. These thinking models, though, they're trained using reinforcement learning to actually use more compute time during inference. So after you ask the question, but before the answer.
So they pause and think.
In a way, yes. Think of it like the model running through potentially tens of thousands of internal steps, exploring possibilities before settling on a final response.
Instead of just the first output.
Exactly. Leads to more accurate, more reasoned answers. And this isn't just for text, it's integrated across multimodal inputs and long contexts, too.
And you mentioned a thinking budget.
Right. You can actually set this budget to trade off performance versus cost and latency. So if you give it a bigger budget, it can work harder, spend more internal steps, and generally achieve higher accuracy on benchmarks. They show this on things like AIM 2025 and Live Code Bench.
That ability to control the thinking seems really useful. But, okay, beyond that capability, what's happening under the hood? What are the architectural changes driving these gains?
Good question. The 2.5 models use what's called a sparse mixture of experts transformer architecture. It's also natively multimodal.
Mixture of experts. Okay, what does that mean practically?
Think of it like having a huge team of specialists inside the model. Instead of everyone working on every single task, the model intelligently activates only the relevant subset of experts for each specific part of the input.
Ah, so it's more efficient.
Much more efficient. It decouples the model's total capacity, which can be massive, from the actual computation needed for any given query. There have also been advances in training stability, how signals propagate through the network, optimization, all trained on Google's latest TPV5P hardware.
And that helps with?
It helps with everything, really, but specifically contributes to handling those huge million-token inputs and big improvements in understanding images and video.
It sounds like these foundational improvements are leading to some really impressive jumps in specific areas. Can you highlight some of the biggest wins?
Absolutely. Let's start with code. Gemini 2.5 Pro shows a massive leap on benchmarks. Live code bench performance jumped from about 30% for 1.5 Pro to over 74%.
Wow, that's huge.
It is. And on 8 or Polyglot, it went from roughly 17% up to 82%. You see this translating into better IDE tools, more complex coding agents, even generating interactive web and mobile apps from multimodal inputs.
Okay, coding is clearly a big one. What else?
Factuality. The 2.0 and 2.5 models are better at handling multimodal inputs and long contexts when checking facts. They can use tools like Google Search more effectively to find and synthesize fresh information.
So they can answer more complex questions.
Right, multi-step queries, tasks that require planning over time. This tech is already powering things like AI overviews in Search for, like 1.5 billion users, and the Gemini app for 400 million.
That's scale. What about long context itself?
Yeah, the 2.5 models are much better at actually using that million-token context. For instance, 2.5 Pro can reliably recall a specific 1-second visual event from a, get this, 46-minute video.
That's incredible recall.
It really makes huge amounts of data usable. Then there's multilinguality. They now support over 400 languages with big quality and speed gains, especially for Indic languages, Chinese, Japanese, and Korean.
400 languages.
And audio. It's not just understanding anymore.
Hmm.
Gemini 2.5 was trained for audio generation, text-to-speech, even generating dialogue audio directly from audio-visual input, all with low latency. The preview TTS models support over 80 languages, control over style, emotion, multiple speakers. It's used in Notebook LM's audio overviews.
So understanding and generating across modalities, video too.
Yes, big expansion in video understanding. Processing about 3 hours of video in that million-token window unlocks new things, like making interactive quizzes from lecture videos or generating animations from demo videos.
Okay, and finally, you mentioned agentic capabilities earlier.
Right. Gemini Deep Research, which uses 2.5 Pro, shows this. It can strategically browse the web for complex queries, prioritize tasks, figure out dead ends. Its score on a tough benchmark called Humanities Last Exam jumped from under 8% to over 32%.
These agentic abilities sound powerful. To make it more concrete, what's a really good example of this in action?
Well, the report details a pretty fun one. Gemini plays Pokemon. They set up Gemini 2.5 Pro to play the classic Pokemon Blue game, completely autonomously.
Okay, how did it do?
Amazingly well, actually. On its second try, it completed the entire game in about 406 hours.
Whoa, that's unexpected. What did that demonstrate about the model?
It showed really impressive reasoning and, crucially, long-term planning. It used specialized tools, which were actually other prompted instances of 2.5 Pro, like a Pathfinder and a Boulder puzzle strategist to solve complex in-game puzzles.
Like what?
Navigating tricky mazes, spinner puzzles, the Safari Zone with its step limit, complex multi-level boulder puzzles like in the Seafoam Islands. Some of these tasks needed reasoning over like 100,000 tokens of game history and planning paths, 150 actions long.
That's complex planning.
Definitely. It also showed long-term coherence. Like, it decided to train specific Pokemon for over 24 hours straight just to beat one gym leader. Or figuring out the multi-step process to get essential hidden moves.
Any really surprising moments?
There was one where it encountered a soft lock, a situation where the player gets stuck. It creatively used the FLY move to escape, which isn't actually possible in that specific situation in the real game.
Yeah.
So it wasn't just recalling training data. It was problem-solving in a novel way.
Fascinating. But it wasn't perfect, right? Where did it struggle?
No, definitely not perfect, and the struggles are very informative. It had trouble directly using the raw pixel data from the screen. It often needed the game state translated into text first.
Okay, understandable.
With very long contexts, especially over 100,000 tokens, it sometimes got stuck repeating old actions instead of creating new plans. It also experienced hallucinations.
Hallucinations. In Pokemon.
Yeah, like becoming obsessed with finding a TA item that doesn't actually exist in that version of the game. Or context poisoning, where bad information somehow corrupted its goals, leading to loops of nonsensical actions. It also fell into topological traps in mazes, getting stuck on easy but wrong paths. And sometimes it showed what they called agent panic, where its reasoning seemed to degrade and it just focused obsessively on immediate healing or running away instead of strategy.
So successes and very clear limitations. That's really insightful. Okay, moving beyond games, what other kinds of applications are we seeing for 2.5 Pro? And critically, How is Google handling safety with these powerful models?
Well, 2.5 Pro is really good at turning diverse inputs into interactive applications. For example, taking a PDF script and making a tool for actors to practice lines.
Hmm.
Or you upload a photo of your bookshelf and it builds you a little book recommendation app.
Turning data into tools.
Exactly. Or converting images into HTML or SVG structures, generating complex simulations like an interactive solar system model. And as mentioned, it's being integrated into many Google products. AI overviews, such as AI Mode, Project Astra, Gemini Deep Research, Notebook LM Audio.
And safety. That's always a huge concern with more capable models.
It is. Google emphasizes their commitment to responsible development. They have detailed safety policies against generating harmful content, plus guidelines for helpfulness, making sure the model tries to fulfill user requests positively. They use automated red teaming.
Where AI attacks AI to find flaws.
Essentially, yes.
What?
Attacking models try to provoke unsafe responses, and those failures are fed back into the training data to improve the model's safety filters and alignment.
Okay. What about the really serious risks, the ones covered by things like the Frontier Safety Framework?
Right, that framework looks at potential risks in really sensitive areas. CBRN threats, chemical, biological, radiological, nuclear, cybersecurity misuse, accelerating dangerous R&D, deceptive behaviors.
High-stakes stuff. How did 2.5 Pro fare?
This is important. According to the report, even with its increased capabilities, Gemini 2.5 Pro did not reach any of the critical capability levels in any of those high-risk areas,
Meaning?
meaning it's considered unlikely, based on their evaluations, to pose a significant risk of severe harm in those specific domains right now. They also test things like resistance to indirect prompt injection, trying to trick the model through manipulated inputs, and the 2.5 model showed better resilience there.
Any other safety points?
Yes. They also found that 2.x models were significantly less likely to memorize and regurgitate long passages from their training data compared to earlier models. And importantly, no personal information was found in the outputs classified as memorized for these newer models.
Well, that was quite the deep dive. We've covered a lot how the Gemini 2.x family, especially 2.5 Pro, marks a big step up in AI. Multimodal understanding, that thinking capability, the jumps in coding, factuality, even playing complex games like Pokemon, and also the safety framework around it.
It really is a substantial leap. And, if you look at the speed of progress, like that five-fold performance increase on Ada Polyglot or the doubling on SWE Bench in just 1 year, it raises a really interesting question for the whole field.
Which is?
How do evaluation benchmarks keep up? When models improve this fast, creating new, genuinely challenging tests becomes harder, more expensive, and needs an even smaller pool of specialized experts. It's something to think about how we measure progress when the goalposts are moving so quickly.